We are now going to look at the second example for determining empirical formula. This example says a compound containing nitrogen and oxygen is decomposed in the lab and produces 24.5 grams of nitrogen and 70 grams of oxygen. It then says determine the empirical formula of the compound. Okay, so now this problem's a little bit different because they are giving you the masses right off the bat. It's not mass percent. So remember our steps here said that if you're given percentages, you would assume it's out of 100 grams, and you would convert the percentages to grams. But if you are already given the grams, then you can begin simply with step number 3. So for this particular example, we are going to start with our 24.5 grams of nitrogen and 70 grams of oxygen and determine the empirical formula of the compound. So we're starting with our grams, 24.5 grams of nitrogen and 70 grams of oxygen. Okay, so our first, now it's the third step because now we can skip ahead. Since we're starting with grams, we can skip to the third step, which says convert the mass into moles. So we're going to change the mass of nitrogen into moles by using the molar mass of nitrogen, which is 14.01 grams of nitrogen per 1 mole of nitrogen. And then we're going to do the same for the oxygen, convert the oxygen, 16.00 grams of oxygen per 1 mole of oxygen. Okay, cancel your units. And now we're going to solve for the moles of each element. So now the moles of nitrogen will take 24.5 divided by 14.01, and what you get is 1.75 moles of nitrogen. Now, when you divide 70 by 16, you get 4.38 moles of oxygen. Okay, so now we know the amount of moles within the compound of each element. Now we want to determine a whole number ratio between the elements. So we divide by the smallest number, which in this case is the 1.75. So we're going to divide both by 1.75. And what this will give you then is 1 mole of nitrogen to, when you divide 4.38 by 1.75, what you get here is 2.5 moles of oxygen. Okay, I'm just going to keep that. It is what it is. I just like consistency. Anyways, so what you see here is that when we divided these numbers for the moles of oxygen, you get a decimal. It does not round to a whole number, okay? So you will keep it as its decimal. Now, in order to write a chemical formula, the chemical formula must be a whole number ratio. We can't have decimals. So in order to make a decimal into a whole number, we need to multiply it by a particular factor. So to make 2.5 a whole number, we can multiply it by a factor of 2. But what we do to oxygen, we must also do to nitrogen. So now this is going to be 2 moles of nitrogen to 5 moles of oxygen, which gives us the chemical formula N2O5. Okay. And now let's take a look at what type of compound this could be. What we have is nitrogen and oxygen. Nitrogen and oxygen are both nonmetals. If we have two nonmetals bonded together to form a compound, we call this a covalent compound. More specifically, a binary covalent compound. So we've learned how to name binary covalent compounds. So we're going to apply that just as practice. Two nitrogens would be dinitrogen, and 5 oxygens would be pentoxide. And that completes our second example for determining empirical formula.